Hello and welcome guys to the last algorithm of our playlist, that is A3C. And after this basically we will be uh, I mean building some games, how AI uh, how AI isn't basically beat human playing the games, beating their high scores, etc. So etc. Okay. And so basically in those tutorial we will be learning how basically we solve any type of different game like Atari, uh, I mean self-driving car, tic-tac-toe games. Okay, these type of game, how we will be building using reinforcement learning agents. So we'll see that in those tutorials. Okay, now let's learn A3C algorithm. So basically this A3C stand for asynchronous advantage actor critic. So this is like a advanced version of uh, like actor critic algorithm that we have learned in the previous tutorial. Okay, so it's like an extension of basic actor critic algorithm that employ multiple agent working synchronously uh, and communicating with a global parameter server. Okay, so A3C is designed to be more efficient in learning from high dimensional continuous state and action space by leveraging the power of deep neural networks. Okay, so on the other hand, AC, or you can say actor critic, is a family of reinforcement learning algorithm that combines the benefit of both value based and policy based method. It involves maintaining two networks, or you can say two neural network, the actor network and the basically that learns the policy by directly mapping the state to action, and the critic network that learns the state value function by estimating the expected return you know from a given state. Okay, so the key difference between A3C and AC is that A3C introduces asynchronous training by allowing multiple agents to update the global network parameter in parallel, which speed up learning process as well. In contrast, actor critic typically train a single agent on a single device. Okay, so that's the main difference between AC and A3C. Okay, now this A3C, or you can say asynchronous advantage actor critic, is a reinforcement learning algorithm that uses multiple agent running in parallel to learn a policy for a given task. So it combines the benefit of both policy gradient and value based method to provide fast and stable learning. So in this A3C there are multiple agents uh, run asynchronously in parallel on different instances of environment, where each agent has a copy of own cop it has own copy of neural network, which is then updated asynchronously based on its own experiences. And the agent communicates with the global network that we will be defining, and then it updates the parameter based on their own experiences. Okay, now this algorithm basically uses actor critic architecture only, where the actor is responsible for selecting action based on current policy, and the critic evaluates the policy, or you can say the state action pairs. So the actor network output a probability distribution over a action space, and the critic network estimates the value of current state. Now the key idea behind actor 3 critic is that it uses the advantage function, which measure the advantage of taking a particular action as compared to average action value. This help to reduce the variance and in the update step, and improve the stability of learning process. So to basically see how it works, let's see the steps. So you can see that from any other algorithm, this algorithm has so many steps. Okay, so now let's understand uh, briefly. So basically what we do first, in the very first step, what we do, we initialize a global network with some random initialized weights, and then we initialize set of worker agent and then their own copy of global network. Okay, and that is what the very first two steps. And after that what we do, each agent run asynchronously on a separate instance of the network, collecting experience tuples of state, action, reward and next state. Okay, so the agent uses its own copy of network to estimate the action value and policy and compute the advantage function. So this is what very different from any other algorithm we have learned till now. Okay, and the agent sends the experience tuple and compute the gradient to the global network. Okay, so the global network then updates its parameter based on the collected gradient from all the agents, and then the global network periodically updates the weight of all the worker agent, and after that we repeat all the from this step, third step, up till the seventh step until convergence. Okay, so this is what we basically do in A3C algorithm. Okay, so let's understand it through an example so that you get it I mean more thoroughly. Okay, so basically let's say in example the AI agent will learn to play chess game by playing against itself using a variant of A3C algorithm. Okay, let's say name it as a A2C. Okay, actor advantage actor critic. Okay, now first the AI agent will initialize its policy and the value function network. After that, these network will be trained to predict the best move and the expected reward for each move, okay, respectively. Now the AI agent will then play a game of chess again itself only. At each move, the agent will use its policy network to select the best move, okay, best move it can, okay, to make, and then use the value function network to estimate the expected reward for that particular move. Okay, so once the game is over, the AI agent will calculate the advantage of each move made during the game. Okay, and the advantage is calculated as the difference between actual reward received and the expected reward predicted by the value function network. Okay, so the AI agent will then use the advantage values to update both its policy and value function network, and the policy network will get updated to increase the probability of selecting moves that lead to high advantage values. Okay, while the value function network will be updated to better predict the expected reward. So further that, the AI agent will repeat this process of playing game, calculating the advantages and updating its network. However, to improve the efficiency of learning, the AI agent will use multiple threads to play and learn from games simultaneously. Okay, and lastly, over time the AI agent, what we will do, it will learn to play chess game at very high level of continuously refining its policy and value function network through self play. Okay, because there are multiple agents simultaneously playing in different threads, and this is what advantage of A3C learning. But obviously it uses so many high computation resource, as well as uh, I mean the time of training also like less, but consumption of power is very high. Okay, so overall A3C algorithm is like more stable and efficient algorithm as compared to AC, making it better suited for deep reinforcement learning problem with high dimensional state and access spaces. And then lastly the closing words will be like A3C is a powerful algorithm that has been successfully applied to wide range of environment, like games like Atari, Robotic Task. Basically, these type of game, it help basically this algorithm. In parallel nature. Now, what parallel nature? Basically, it allow you to take advantage of multi-core processor and GPU acceleration that other algorithm can't help us do it. Okay, so making it much faster than any other traditional RL algorithm. So this is how things work in A3C. Now let's look at example of A3C. Okay.